All right, let's talk about the 2.7, 2.8 learning check assignment. In 2.7, we were focused on a numerical description of a function, whether it was in a table or a list of ordered pairs, and then the inverse of that function. The inverse of a function has input and output exchanged. So if I wanted to write the inverse of this function, since it's a numerical list, this is my k function, the ordered pairs 0, 15, 1, 12, and so on. The inverse function is going to flip the input and output for each of the ordered pairs. So instead of 0, 15, the first one in the inverse would be 15, 0. And then instead of 1, 12, the inverse would have the ordered pair 12, 1, etc. And so you would list all of the ordered pairs. I'm just going to type the first two. Right? So you would list all of those for the inverse, k inverse, as a function, as a numeric representation of a function. Then the domain and the range. So the domain, this is the domain of the original function, can't spell it right there, domain of the original function k. And so domain is all the inputs, and this is a discrete function, this numerical list. So we're going to list all the domain values. So 0, 1, 2, 3, and 9. It looks like the complete set of input values in the original function. The original function is k. This is the domain of k. And when we do the range of k, we would do something similar, but we would list all of the output values. The output values are not already in order like the inputs were 0, 1, 2, 3, 9. So I would try to reorder these. It looks like -5 is the smallest, and then 6, 7, and so on until you have your full list. I'm not going to complete that, but until you have your full list of your range of k. All right, so that would be the first couple. Next, it asks me for the domain of k inverse. So the domain of k inverse is, again, the inputs from this function's list. And again, I don't have all my ordered pairs in here, but you would look at all the inputs and you would get them in order. So there would be a few of them, and then you'd have your 12 and your 15 and so on, so that you had all the inputs for the inverse function. Same thing for the range of k inverse. You're going to finish your k inverse function and you list your range values as the outputs of that function, which appear to be 0, oops, I forgot to type 0, and 1, and so on, filling out the range of that function. Now, you should notice when you complete the range of k inverse that it is the exact same thing as the domain of k because the functions are inverses. Their input and output swap. We changed the order of the coordinates. The x's became the y's, vice versa. So the domain values, which are the input or x values of the original function, must now be the y values of the inverse function. X values became y values and vice versa. So you'll notice some overlap here with the domain of k inverse and the range of k. All right, and then determine k of 1, k inverse of 12, and so on. So if I look at just one or two of those, look at 6 and 7. K of 1, k of 1 is, back up to my numerical function, 1 is an input for k, 1 is an input for k, and so its output is 12. So k of 1 is 12. And then k inverse of let's just say I asked you what k inverse of 15 is. I don't think they do, but I don't have my full k inverse function listed here. If they asked me what k inverse of 15 was, I would say, okay, 15 is an input, not in the original function, but 15 is an input in the inverse function. And what is its matching output? Its matching output would be 0. So k inverse of 15 would be 0. So I didn't complete my k inverse function, so you can't see the list of values. Oh, I could have done this one since it was 12. So k inverse of 12 is, since I have 12 in my list right here as an input for the inverse, its output is 1. And then I don't have enough listed in here, my inverse function, to get the last one, so you need to finish your inverse function to get k inverse of 7. All right, so that is the first section for this learning check, 2.7. It's all about the numeric representation of functions and their inverses. Next, we're going to look at 2.8. This is about the algebraic and graphic representation of inverses. So there is a guide, directions in the book in 2.8. I'm looking up the page real quick. I think it's page 245, which describes how to find the inverse of a function algebraically at page 245. So we're going to use those steps here for the first function. I want to find the inverse algebraically. Step 1, write the equation for y in terms of x. So it originally says f of x equals 3x minus 7, but I want to rewrite that in step 1 as y equals 3x minus 7 so that it's in terms of x and y. So I'm changing it from function notation just to equation notation. Then, step 2, solve for x. Okay, solve for x. So I need to get x by itself. To get x by itself, that negative 7's got to go, so we're going to add 7 to both sides, right? So you've got y plus 7, which is y plus 7, equals our 3x on the other side. Okay, so I need to get x by itself, not 3x, so that 3 has got to go. So we are going to divide by 3. Oops, that was the wrong key. There we go. And when we divide by 3, we're going to make sure we distribute that division so every little piece gets divided by 3. So I have y divided by 3 plus 7 divided by 3 equals x. And then step 3, if you are in a non-contextual abstract function, which we are in this case, non-contextual abstract meaning that there's not a situation tied to these variables. I don't know the meaning of x and y. They're not special letters like C and D or whatever else might be situational to a contextual problem. So if I'm not in a contextual situation, we can interchange x and y. So we are going to copy paste and we're just going to switch the letters. So we are going to make this x equals, or x over 3, I mean, plus 7/3 equals y. And then we can get it back in inverse function notation. So y back to f inverse of x equals our x over 3 plus 7/3. So that would be the result for the very first one. Now, sometimes if you're looking at homework on a view and example, they may have written it slightly differently. So if we go back and look at this step here, when we divided both sides by 3, I chose to divide everything by 3 because I'm typing and it just makes it look better. So I distributed the division. I also could have maybe chosen to not distribute the division. If I did not distribute the division, though, I'm still dividing this entire side by 3 and this entire side by 3. And so I would have the entirety of y plus 7 divided by 3. And so I would want to represent that with parentheses if I'm in this view. Or let me get a Desmos tab open real quick. Just to show how it would look. Maybe I can do it in Math. Because again, it doesn't look very pretty right here when I'm showing it on this little notepad screen. So I can show what that should look like in this. So I'm taking y plus 7 and dividing it by 3. So that's how it should look. It should be that entire quantity divided by 3. I prefer just to go ahead and distribute it, but sometimes they're not going to distribute it when they do the view and example. So there are 2 ways, switching those into x and y's, switching those variables again, 2 ways that you could have represented your answer. We could have had f inverse of x being this thing, this big fraction, or I could have had f inverse of x being x over 3 plus 7 over 3. Apparently, I'm having issues typing. There we go. And again, it's the same thing, right? Because if you distribute this 3 across the denominator, it goes under the x and under the 7. So there's 2 ways to write it. They're both beautiful. And either one's accepted in my math lab. They're both accepted on paper. I don't care which one you use, just trying to show it's not always super pretty when I type the math versus when I write the math, so wanted to make it look prettier. All right, so Notepad, we're going to go away because you're not the best tool for writing. I'm going to write the rest of my stuff in this thing. It's just a math type editor. Okay. Similar for all the rest of them. We can look at one more. Let's take a look at 7 just because. I have the g of x function equals, I get to type my pretty fraction here, 4 minus x across the top, 3 across the bottom. Once again, the steps on page 245 tell us to rewrite this as a y equals equation instead of a function and solve it for x. So I know that when I solve for x, since I have a fraction here divided by 3, the very first thing I need to do is multiply both sides by 3. So 3 times both sides, we'll get those 2 3's to cancel off. So I'll get 3y equals 4 minus x. Want to get x by itself, so got to get rid of the 4. So we're going to subtract 4 from both sides. And that'll give us 3y minus 4 equals negative x. Don't want negative x, want positive x. So I can divide off the negative 1 or multiply everything by a negative. So it's going to make it negative 3y plus 4 equals positive x. Then switch your letters. So instead of negative 3y, we'll have negative 3x plus 4 equals y and pop it back in a function notation. This function was called g. So in inverse notation, it'll be g inverse of x equals, and copy paste, equals the negative 3x plus 4. So that would be our answer for number 7. Again, y equals, solve for x, switch the letters to x and y, and rewrite in inverse function notation. That should be all for the rest of 2H. There's just several examples where we get to practice those strategies.